This Olympiad math question is quite interesting. 3 raised to t times 3 raised to t times 3 raised to t equal to 36. This left hand side is the same thing as writing 3 raised to t plus t equal to 36. T plus t plus t, that is 3t. So we have 3 raised to 3t equal to 36. Let us take natural log of both sides. So we have log 3 raised to 3t equal to log 36. Recall that from one of the rules of logarithm, let's say we have log a raised to m. This is equal to m times log a. Applying this property to this guy, we have 3t times log 3 equal to log 36. Let's continue. Let us divide both sides by log 3. So we have 3t times log 3 divided by log 3 equal to log 36 divided by log 3. Log 3 cancel log 3 on the left side. We are left with 3t equal to log 36 divided by log 3. Don't forget that we can rewrite 36 as 9 times 4. That means we are going to have 3t equal to log. In place of 36, we write 9 times 4. So we have 9 times 4 divided by log 3. 3t is equal to, also from one of the rules of logarithm, let's say we have log a times b. This is the same thing as writing log a plus log b. Applying this property to this numerator, we are going to have log 9 plus log 4 divided by log 3. 3t is equal to, we can rewrite 9 as 3 square. Likewise, 4 could be written as 2 square. So this numerator becomes log 3 square plus log 2 square divided by log 3. 3t is equal to, log 3 square is the same thing as writing 2 times log 3. By just moving this power down, plus log 2 square can also be written as 2 times log 2. By just moving this power down, divided by log 3. Let us continue. 3t is equal to, this right hand side could be written as 2 log 3 divided by log 3 plus 2 log 2 divided by log 3. 3t is equal to, log 3 cancel log 3, we are left with 2 plus 2 log 2 divided by log 3. Recall that whenever we have log a divided by log b, this is equal to log a base b. Have this property in mind. So from here we have 3t equal to 2 plus 2. Applying this property to this guy, we have log 2 base 3. Let's continue. Now let us divide both sides by 3. Doing that, we have t equal to 2 plus 2 log 2 base 3 divided by 3. This is the value of t. For this Olympiad math question, t is equal to 2 plus 2 log 2 base 3 divided by 3. But let us verify if this answer is actually correct. So, verify. The question says 3 raised to t times 3 raised to t times 3 raised to t is equal to 36. And the value of t that we have is 2 plus 2 log 2 base 3 divided by 3. Let's plug it into this power. That will be 3 raised to 2 plus 2 log 2 base 3 divided by 3 times 3 raised to 2 plus 2 log 2 base 3 divided by 3 times 3 raised to 2 plus 2 log 2 base 3 divided by 3. And we claim that all of this is equal to 36. What do you observe here? You will observe that this left hand side have the same base throughout. That means we can just add these exponents. Adding the exponents, we are going to have 3 raised to 3 times one of these exponents, 2 plus 2 log 2 base 3 divided by 3 is equal to 36. This is our claim. Clearly, this 3 takes care of this 3. We are left with 3 raised to 2 plus 2 log 2 base 3, and we claim that it is equal to 36. It is possible to rewrite this guy as 3 square times 3 raised to 2 log 2 base 3 equal to 36. What is 3 square? 3 square is simply 9 times 3. If we move this guy 2 up, we're going to have log 2 square base 3 equal to 36. So we have 9 times 3 raised to log 2 square is simply 4 base 3 equal to 36. At this stage, we have to recall a very beautiful property. It says a raised to log b base a is the same thing as b. That means from here we are going to have 9 times. Applying this property to this guy, you will notice that our a is 3, a is 3, and our b is 4. That means all of this guy becomes 4 equal to 36. 9 times 4, that is simply 36, equal to 36. This shows that the left hand side is equal to the right hand side. Thus, indeed, our value of t is equal to 2 plus 2 log 2 base 3 divided by 3. This is the required solution for this Olympiad math question. That's it. Thanks for watching.